Hi, welcome, folks. Welcome to the Calnex webinar. We'll just give a couple of minutes for folks who might take a little bit of time to join, and we'll get started. Just wanted to sound that out without letting you hang there in silence. So we'll just wait for exactly another 90 seconds on the dot, and then we can get started. It's 3 minutes past. Should we wait for another couple of minutes? Should we get started, Stefano? What do you think?
Yes, let's wait.
Okay, sure. We'll just wait for another couple of minutes and we can get started. All right, we just passed the top of the fifth, so I think it's a good time to get started while we see some more people are joining in. So good afternoon, everyone. Welcome to the Timing and Sync webinar hosted by Calnex. My name is Mahendra. I'll be your host today shortly. I also have Stefano with me. Stefano is the uh, strategic technology manager for Calnex. Just to give you a quick introduction, Stefano graduated in telecommunication from Rome, La Sapienza. He had a long stint at Ericsson, and he's currently heading the strategic technology at Calnex Solution. He's also currently contributing to the ITUT subgroup 15Q13. He's serving as a reporter IEEE 1588 and other relevant synchronization, standardization bodies and forums. I mean, obviously, he does not need an introduction in the synchronization space. He's published several international journal papers and he's delivered talks at various conferences. He's also a member of the steering group of the International Timing and Sync Forum and a member of the steering committee of the workshop on synchronization in telecommunication systems. So we're happy to have Stefano here with us today. He'll take us through the recent standards, the updates, and how it's going to impact all of our testing and the way forward. So I'm happy to have all of you here. There is a special Q&A box that you'd see at the bottom of your Zoom screen. If there's any questions along the way, please feel free to drop them in the box. I'm sure some of those questions might be answered through the course of Stefano's slide deck, but if it's not, we'll get to these questions at the end of it and we can go through them. So, yeah, without wasting much time, Stefano, over to you.
Thank you, Mahendra, and good afternoon, everyone. I hope my voice is clear enough.
Yes.
And I'm sharing also some slides. So today I plan to, after a brief introduction, to focus on some of the relevant updates from the ITT synchronization activities and recommendations. However, I'll also try to show some other related bodies, what is happening in other groups like IEEE as an example. But let me start as a brief introduction. You may know that this is the 20 years anniversary for Calnex. It's an important date. And to be active in the standards is actually one of the key initiatives from the very beginning, I would say. Here is an example of you see, you can recognize the name of the founder of Calnex, Tommy, already after 1 or 2 years after the foundation of Calnex, actively representing Calnex in ITT. But as I said, ITT is a key part of the standards related to synchronization, in particular the group called Question 13 that I am chairing. And essentially the reason is that it is collecting some of the main experts in the synchronization area, and for many years has been active on various technologies defining standards for synchronization. However, there are important groups. I mentioned IEEE, of course, for the IEEE 1588 standard, that is a key timing protocol used in many industries, but there are other important projects and standards that if we have time, I can maybe mention some examples, what is happening there. And ORAN for the access, radio access for the front haul, also there are important related activities. Most of them are really making use of ITT. And obviously 3GPP has been providing for many years some of the key requirements of the end applications like in mobile networks. And 5G has been one key area that has driven most of the time synchronization requirements. And now, as you know, is moving towards the 5G evolution and towards 6G. But let's move to ITT. So here is a table that summarizes, I would say, all of the ITT recommendations related to synchronization that are being developed by Question 13 or that have been released in the last few years, or actually some of them, like those related to OTN or even to the interfaces, are actually very old. The initial releases is from the 90s, but they are continuously updated. Like the G.703 has introduced in the last few years, like 1PBS type of interface, as an example. You see here there is a kind of color coding. Some of the recommendations are shown as green because are more or less stable. Nevertheless, they are continuously updated. As an example, 8273.2 that is dealing with the boundary clock requirements is continuously updated, and I will show some of the examples that has happened in the last few months. Those that are orange or yellow are even more ongoing work, and but I'm not going into the details of this table. I just wanted to give you a kind of summary, just to give you the feeling of how many recommendations are being developed by Question 13. So one important example of recent updates, and when I refer to recent, I mean in the last 6-12 months. So this is the time frame I am addressing today. For the synchronous Ethernet clocks, in one of the last release of the G.8262.1, that is the enhanced synchronous Ethernet clock recommendation, has been with the addition of the temperature variation of noise generation. So you can find in the latest revisions of the 8262.1 a new mask. You see the upper part of this MTI mask has been added recently and is related to the noise generation characteristics under temperature variation conditions. Other important updates to the synchronous Ethernet clocks are shown in the next couple of slides. In particular, in one of the appendixes of 8262, there is a list of the interfaces that can be used to carry synchronous Ethernet. And recently, the list has been updated, added some interfaces that has been standardized recently by 82.3, like the 800 gigabit interfaces. Quite important is also one additional requirement that has been added at the last meeting in 8262.1. This is related to the jitter generation and jitter tolerance for the 10 gigabit and 25 gigabit interfaces. So you might have been aware that for quite many years, 10G and 25G were not addressed completely in terms of jitter into the 8262.1. It was in 8262, but for several reasons, it took quite some time to agree on requirements for the enhanced synchronous Ethernet clock. So now you will find in 8262.1 new requirements for the 10 gigabit and 25 gigabit. In particular, there is an optional requirement to comply with the same jitter requirements that you can find in 8262. So this is specified as optional, but there is a mandatory requirement, quite a new type of requirement related to jitter generation that is related to the control of the jitter generation at the lowest, at the lower frequency range. You see, between 10 hertz and 200 hertz, it is important to verify that the clock does not generate noise above a certain mask. And the mask is exactly the same mask that you can find in the tolerance, in the jitter tolerance of the 8262.1 clocks. Because in this reason, in this way, it is possible to allow the next connected clock to tolerate the signal noise and be able to lock to the incoming reference. So this type of new requirement is also leading to define new testing methodologies, and we are actively contributing to that. So hopefully already in July, in a few weeks, we can get some agreement on how this will be able to be tested. And afterwards, of course, as Calnex, we will be able to support our customers with a proper methodology to verify this new requirement. A couple of other updates related to clocks. Now I'm moving to the time sync clocks, 8273.2. In particular, the requirement related to the long-term holdover. So this is when a clock is operating without the support of synchronous Ethernet, because there is a I'm sorry, this is the opposite. Is when PTP is lost and the clock is operating only with the synchronous Ethernet as a kind of holdover condition. And for this type of situation, you can find in 73.2 new requirements related to the class C clock, both in constant temperature and variable temperature. Of course, all of these also can be tested by Calnex. Another update that you can find in the last year in 73.2 concern some clarification on the long-term rearrangement of synchronous phi. So this is the case when for a long period the clock is operating only with PTP. So here is the opposite situation. There is a failure in synchronous Ethernet network, and the clock is operating only with PTP. And also for this requirement, there is a testing methodology that has been defined in 8273 that clarify some of the details how the test must be implemented. Still in 8273.2, there is an important update that has been done in the last couple of versions of the draft. You will see the latest text. It will be published in a few months. So this is still in the draft, but I want to mention because it's quite important. So there is an appendix 12 in 73.2 that highlight the importance of controlling the error that can be added by some optical pluggables, like for instance PAM4 pluggables. The issue is that these pluggables can add significant asymmetry. So maybe you have a perfect design of the system that is controlling the constant time error below 10 nanoseconds, as an example. But then when you insert the optical pluggable, you may notice that the error can increase significantly, even several tenths of nanoseconds. And this is due to some of the technology that, if not designed properly in these pluggables, can create this error. So now you find in this appendix some good reference on some of the methodologies that has been defined by a group called MOPA, is a Mobile Optical Pluggable Alliance, that clarify or let's say recommended to characterize the performance of the pluggables. So to verify what is the error that it can be added by each pluggable. And essentially by characterizing the average asymmetry, characterizing the error, the uncertainty of the pluggable, it is possible for the boundary clock to control the error. If you know what is the average of the asymmetry, the host can use this to compensate for the non-asymmetry. And to do that, the relevant pluggable groups like SNIA or also the OIF CMIS, they are updating the memory maps of the pluggables so that they can be populated with values of these average asymmetries so that the host can read those values and compensate for that. Part of the values that can be put into these memories concern also the expected uncertainty. So, for instance, you may find values like 20 nanosecond asymmetry, and then you can use that to compensate for the asymmetry. And then you can see also an additional value per each lane that indicates what is the uncertainty. So it could be like plus minus 2 nanoseconds uncertainty, plus minus 5 nanoseconds. In this way, you are also able to design properly the system so that if you want to meet class C with 10 nanoseconds, you may want to make use of a pluggable where the uncertainty is less than a couple of nanoseconds, as an example. And this is something that you now, by means of proper testing process, is possible to characterize, and these values can be used to populate the memory maps of the pluggables. This is an example of a recent update from the SFF 8472 and the SFF 8636 for the 4-lane. So you see in the memory map, you see a number of parameters. In particular, you see the average per lane. So you can the host can read the average delay on receiving and transmitting direction that can be used to compensate for the asymmetry. In addition, there is also this delta Rx max and delta Tx max. That is the worst case uncertainty I mentioned before. And this is important because this delta value indicates, let's say, whether a pluggable is suitable for a certain design. I want to mention also a few other updates, like you can find updates on the profiles in the 75, 75.1, 75.2, and various additional options have been added mainly to allow a better control over the performance of PTP networks. As an example, in 75.1, you can find now the option of enhanced accuracy matrix TLV. This is a TLV that can be used across a chain of boundary clocks or transparent clocks, where each clock can add on the fields of the TLV the expected time error that can be added by this clock. So the very last clock in the chain, by reading the accumulated time error, can get an understanding what is the expected worst case performance from this PDP flow. Another important update from ITT I want to mention is a new document, Supplement 92, that deals with the synchronization for data centers. This has been already published. There will be a new update in July, but it is a quite important document. It lists in some tables the target performance in a data center. You see the values are very similar to what you can find in telecom. So some different classes, target of class performance, depending on the application that you want to support in a data center. And you can see it can ranges from 200 nanosecond, the error between different servers in the data center, to 5 microseconds. You can see models where the requirements apply. and also some testing methodology, how to verify the performance of a server, the clock in the server, the CPU clock. And it's important to mention that very often, or let's say, you can get very good control of timing performance at the input of the NIC card, because this can be delivered at the hardware level. However, when the timing is then forwarded to the software, to the end application, to the CPU clock, unless there are not special design in place, the performance can be degraded quite significantly. However, there are ways to control the performance, like precision time. This is a precision time protocol, is very similar to 1588. Precision time measurement is the actual name, and is, as I said, is a kind of 1588 type of two-way protocol that can be used to control very accurately the timing, also at the end application. And you see here is an example of a setup that can be used to verify the performance of the timing at the end application. The OCP, Open Compute Project, recently also published some testing guide for the clocks using data centers. And these are very much based on the methodologies that have been defined in ITUT. There are, you can find in the slides at least a summary of the recommendations that have been approved in the last few months, with the summary of what has been added, and also what is planned to be released in July, in a few weeks. I can maybe show the supplement 92 for data center. There will be additional requirements and additional details on testing. And the 62.1, the jitter specification I mentioned before, also will be consented in July. I think we have time for some example of what is going to happen in the next few months. Of course, the data center will continue to be one key area, synchronization in data center, because it's quite important, especially for AI cloud, where having synchronized servers also should enable better control over the performance, the latency, and the power consumption. And among the things that need to be completed in the synchronization for data centers is a definition of the timing protocols and profiles that can be used in data centers. In particular, there are a couple of options that are being considered and that can apply to different type of environments. One option is based on multicast, Ethernet multicast profile, and the intention is to develop a new profile. The preliminary name is called Full Timing Support Lite. It will be a new recommendation that will be based on, will be very similar to 75.1, but without the support of synchronous Ethernet and with a lower packet rate. As an example, 1 message per second. This type of profile should allow to meet very stringent requirements, like the 200 nanoseconds I mentioned before. Another type of, let's say, not a profile, but a new timing protocol that is being considered for data centers is what is being developed in IEEE in 1588.1. And if we have time, I'll spend a few words on that. But basically, this is an IP unicast type of profile that is intended to be very similar to NTP. It's a client-server type of profile, and the reason is to make it stateless type of profile, so less power consuming for the servers and the clocks in the network, in the data center network. Regarding the FTS Lite, I think I mentioned the key points before. So it will be a low packet rate. it will be very similar to 75.1 based on delay request and delay response. And of course, it is full-time in support. So it will use boundary clocks primarily. There is still discussion whether transparent clocks can be useful or not in this environment. While for the 1588.1 is the opposite, essentially. So basically, it can work in a partial time in support without any clock in the clock chain, or it could make use of transparent clocks, but no boundary clocks. Other points that are being developed that still need to be completed in ITT in question 13 concern the clocks. In particular, for class D clock, there is still the need to define some of the details. Currently, there is only a requirement on the maximum absolute time error filter in the low frequencies with 5 nanosecond target. However, there is a need to split this into a constant time error component and dynamic time error component. And this is not an easy task because it looks like there is a need to also define a better enhanced synchronous signal clock. So there is also discussion to add a new type of 62.1 clock that can be used to support the class D clock. Another work that is being done in question 13 is enhancement of the partial timing support. There is some experience from some operator based on some proprietary technology. And the intention is to make use of some of the tools that have been developed in this context to enhance 75.2, for instance, or in principle to use a new timing protocol if it is more suitable. But the key aspects are to use a much higher packet rate than currently used in 75.2, even some thousand of packets per second. And also to make use of the management network to control if there is any change in the asymmetries of the link. So there is a first document that is planned for July. It will be mainly kind of high-level kind of technical report. It's a supplement just providing the high-level principles. And maybe next year it will be possible to release something more pragmatic that can be implemented. One final point I want to address from ITT concern the need to increase the resiliency. So, the GNSS is very open to attack, especially in recent geopolitical conditions. And there are groups like the IEEE 1952 that is working at defining some different resiliency levels, how much the GNSS receiver is robust. And similar concepts have been adopted in ITT. First of all, defining means to increase the robustness of the network when GNSS is lost. This means better holdover, even a network of primary reference time clocks, the coherent PRTC concept. So creating at the highest level of the synchronization network, a network of PRTC, so based on atomic and clock technology and GNSS, they can keep the performance of the network even below 100 nanoseconds for several months. And part of the discussion is how to apply the resiliency levels I mentioned before that are being defined by 1952 as part of the telecom context. So this is something that will be part of a new recommendation. 8274 is a recommendation that has been released last year that is focusing on the architectural aspects of the time synchronization. And the intention is to add some resiliency requirements as part of the 8274. Related to resiliency, maybe it's interesting to mention that what has been added in 71 that is the network limits for time synchronization, is to define a model where part of the time distribution is done over the 5G radio. So you can find a chain of boundary clocks and then a radio base station delivering a timing to the end application. And there is a model with the end-to-end budget for this type of setup. And this could be useful, for instance, where you need timing over 5G as a backup to GNSS, as an example. Another point that is being just started to be discussed in question 13 concern the monitoring of GNSS receivers. So there is a new document, a supplement PRTC monitoring, that will collect parameters that can be used by PRTC to monitor the operation of the GNSS receiver. I think we have maybe your minutes. Mahendra, can you confirm?
Yeah,
So you have a couple of
sure,
more.
Stefano. Yeah, we have some more time. You can go ahead.
Okay. Yeah, maybe just to give you some examples on other groups, what they are doing, because this is very much related to the work done in ITT as well. I mentioned the 1588.1. So as I mentioned, this is a client-server protocol. There are still discussions, but there are already some initial agreements. The plan is maybe to have a stable document, perhaps even approved in 2027. But I would say the key point is that the timing exchange is very simple. It's based on client-server exchange, making use of the sync message. So the format of the message, of the timing message, is the same as defined by 1588. And you can see the sync message in both directions. Of course, there is a need to integrate with additional information that can be carried by a TLV. As an example, the TLV can provide information on whether the sync message is a request message from the client to the server or a response from the server to the client. And as mentioned before, it can operate in full timing support or partial timing support, but the full timing support is only assuming transparent clocks. 802.1, also there have been important updates from IEEE. These are timing standards based on 802.1 AES profile. I would say the key updates concern improvements of the resiliency with some options like hot standby that allow to have in parallel multiple grandmasters. And then the IEC IEEE 608.02 is an industrial automation profile, also has been recently published. Again, this is based on 802.1 AES. All of these, let's say, standards from 802.1 are mainly addressing industries like industrial automation, automotive, aerospace, where resiliency is a key requirement. So that is why you find this type of additional options to increase the resiliency. And there are related to that also potentially in the future new way test, because one of the functions that is very much used in this context is the rate ratio. Basically, the frequency is distributed across the network via information that basically provides the difference between the grandmaster frequency and the frequency of each clock. This information is carried over a parameter, rate ratio, and part of the testing methodology will require to verify the operation of this parameter. Important also the initiatives in ORAN related to security. So there are various type of security attack to PTP that have been studied in ORAN. And as part of that, there is a new test specification that is under development. It's still not ready, but Calnex is very much active here to contribute on how the various security attack can be verified the robustness of the ORAN clocks, the ORU and the audio. So that's an interesting area that will be also addressed by Calnex. So here, of course, as related to that, there are the requirements on how to add the security to PTP, and it could be either PTP over MACsec or using the 1588 TLV. PTP over MACsec is probably probably it will be the most common in the future because it's kind of more robust. However, there is also some interest on the 1588 TLV. And then as part of the material, you find also summary on the various specifications that have been updated by Yoran in the last few years. I think maybe, yes, you find as part of the material also some updates on the non-terrestrial networks specified by 3GPP, and that in the future may add the new requirements in terms of synchronization. 6G, it is still far from us, but it's interesting to look at what is happening. So the expectation is that this will be deployed in a few years, in 2030. And we are, of course, looking at what will be the impacts on timing and synchronization. Possibly new, more stringent requirements will be required. Okay, I think I have completed my overview, and this picture is from the Paris meeting with Question 13, where we were hosted by BIPM, that is the center of where UTC time is created. And we are being kindly hosted by the department, 10 department. So that was a nice occasion we had a few months ago. Okay, thank you. I believe we have time for some Q&A.
Yeah, excellent. Thanks so much, Stefano. Folks, we also have Santosh here, the India Business Development Head. And Santosh, over to you for, I think I saw a couple of questions in the chat, and if there's anything else in the Q&A box, would you please go through them?
Absolutely. First of all, thank you, Stefano, for your time. I really appreciate you coming on the call for us and giving the guidance on the standards. I think few of the questions I've just highlighted here. I'll just read the questions. If you can answer one by one. You mentioned on the slide somewhere that optical modules have latency or asymmetry inbuilt. Is there a time or a budget defined by ITUT for these optical modules, or is just depend on vendor to vendor how they define it?
Okay, no, maybe I can go back to the slide as well. Can answer to your question. It's a good question. So basically, this group MOPA has defined a methodology where defining classes of pluggables based on the ITUT clock classes. They have defined a class defined as a percentage of the error defined by the ITUT class. So to be clear, class C.10 is a pluggable that contribute by no more than 10% of a class C clock. So class C clock is 10 nanosecond, as you know, constant time error. And if you find a class C.10 pluggable, this means is no more than 1 nanosecond.
Wow.
You have to be careful because you have to add twice this contribution because you have in the clock chain, you have always two pluggables, part of the system. You have the input and the output. So if you take a class C.10, it will probably be suitable to design a class C clock.
Right. Thank you very much. Let me move to the next question. This is on data center. You mentioned in some of the slides that data center RT or relative timer is about 1 microsecond. Would this be achieved also Syncy? So data center switches need to have Syncy inbuilt in that, or it can only run on PTP?
Well, the intention, and I mentioned before, there is a study about that, is to study a setup where possibly without Syncy it's possible to meet this requirement because sometimes the clocks used in data centers do not support synchronous Ethernet. So this is why it's under study. So that's
Right.
the studies.
Okay, I've got a third question here. I think this is more to do with security you mentioned last. I think various security methods are being deployed. I think one of the things I think some of people have looked at is MACsec. Is there a discussion of MACsec for PTP? And is there a time or a budget defined with that?
So I would say I mentioned before ORAN because in fact ORAN is for now is the only group that specified some normative requirements, and in particular they provide options. Is not a mandatory requirement, but is an option. Optional requirement to support PDP over MACsec. In IQT, you find, however, some detailed clarification that if you carry PDP over MACsec, you have to make sure that your design is able to meet whatever is your target requirement.
Okay.
But it implies that you have to do the design properly, because otherwise MACsec could modify the performance.
Okay, got it. Okay. I've got one more question, if you don't mind. This is all to do with the 12th of June when Starlink's goes IPO. I think I would like to pose a question. You already answered the question, I think. I just want to ask once again. NTN going on 5G, I know it would be more of a transport, but if you can just highlight as to why PTP cannot be deployed in NTN network if it's used for, say, 6G communication from NTN network itself. Can you just highlight that?
So when currently, let's say the NTN standard, I think I have one slide here, yes. Basically, because of the issue of delay across, let's say, the satellite links, is only specified in terms of with FTD type of technology. FTD doesn't require time synchronization.
Right.
And in fact, we also have done some tests, and you are able to meet some loose time sync requirements today. But in fact, NTN it can mean many different setup. In particular, two main categories are transparent mode, when basically the satellite is only transparently carrying the payload and timing. But there are possibilities where you can implement part of the base station on the satellite, like the ORU or the ODU. And potentially this may add a new type of synchronization test activity to be performed, depending also whether in the future it will evolve towards TDD. So it's an interesting new area to consider.
Correct. Thank you so much, Stefano. I don't think any more questions on this at the moment. First of all, thank you, Stefano, for your time. Mahindra and Sai and Arun, who's not on the call today, I think really appreciate you arranging the session for everybody. I just wanted to ask Mahindra, would these slides and recording would be shared with everybody on the call, or would it be shared with everybody who is registered for the link?
Sure, I think we can share it with all of the registrants, and maybe we can put it up online, and we can share the link to the drive where they can download it from. That shouldn't be a problem. Of course, I'll take Stefano's permission before sharing it, but I think that we can share the content.
Perfect.
Sure. And you can share also the PDF I sent earlier.
Okay, excellent. So yeah, we'll put it on online drive, and we'll send you the links, I guess.
Perfect. Once again, thank you very much. I think we will be doing something similar in course of time, 6 months time again probably, and we will and probably we're hosting a similar session what we did last time in September. Uh, Please keep yourself updated on the LinkedIn profile, LinkedIn page what Arun has created. So we'll post a lot of stuff on that, new IT stuff, new PTP stuff happening on that portal. Thank you very much. Mahendra, any last words?
No, thanks everyone. Thanks for joining. Thanks Stefano. Thanks Santosh. Thanks Sai for all the help. I think this was a great session. I hope all of you all enjoyed it. If you have any questions, any comments, we'd love to hear from you anytime, of course. And yeah, anything else, please feel free to reach out, and have a wonderful rest of your day.
Thank you.
Thank you. Bye,
Thank
everyone.
you. Bye bye.